UniKL. Kita terbilang.
Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Mencari peluang. Menjadi cemerlang. Menjadi cemerlang. UniKL. Wow, UniKL. UniKL. Wow, UniKL. Satu amanat kita junjung sama. Tak kira di darat, laut dan udara. Cium tangan mama papa, tanda janji. Kata pasti di kota, buktikan pada mereka. Bawa akal, jadi bekal. Pikul padi, untuk berisi selamat jiwa. Dikandung kental, menyerah kalah. Tolak ke sisi. Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Mencari peluang. Menjadi cemerlang. Menjadi cemerlang. UniKL. Wow, UniKL. UniKL. Wow, UniKL. Satu matlamat, terbang gapai mimpi. Renangi era baru, kejar misi frekuensi. Pengemudi angkatan, nahoda kemajuan. Jauh manapun ada, ciptakan menjadi nyata. Tetap cekal, jangan lalai. Tetap gentar, jangan nolai. Setinggi manapun, akan capai. Kita melonjak dari lantai. Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Mencari peluang. Menjadi cemerlang. Menjadi cemerlang. UniKL. Wow, UniKL. Wow, UniKL. Wow, UniKL. Wow.
UniKL. Kita datang. UniKL. Kita terbilang.
Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Mencari peluang. Menjadi cemerlang. Menjadi cemerlang. UniKL. Wow, UniKL. UniKL. Wow, UniKL. Satu amanat kita junjung sama. Tak kira di darat, laut dan udara. Cium tangan mama papa, tanda janji. Kata pasti di kota, buktikan pada mereka. Bawa akal, jadi bekal. Pikul padi, untuk berisi selamat jiwa. Dikandung kental, menyerah kalah. Tolak ke sisi. Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Mencari peluang. Menjadi cemerlang. Menjadi cemerlang. UniKL. Wow, UniKL. UniKL. Wow, UniKL. Satu matlamat, terbang gapai mimpi. Renangi era baru, kejar misi frekuensi. Pengemudi angkatan, nahoda kemajuan. Jauh manapun ada, ciptakan menjadi nyata. Tetap cekal, jangan lalai. Tetap gentar, jangan nolai. Setinggi manapun, akan capai. Kita melonjak dari lantai. Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Mencari peluang. Menjadi cemerlang. Menjadi cemerlang. UniKL. Wow, UniKL. Wow, UniKL. Wow, UniKL.
dari segi dia punya step to step mengenai engine performance ECU tuning lah. Okey, jadi saya ucapkan selamat datang kepada semua. Terima kasihlah kerana sudi meluangkan masa anda semua untuk join sesi kita pada petang ini. Okey, so jadi tak lupa juga kepada orang kata para boleh dikatakan penceramah lah pada hari ini yang kita jemput daripada seksyen otomotif iaitu Dr. Rifki Izzuan dan juga Encik Edilan yang akan orang kata memberikan segala maklumat lah mengenai daripada tajuk kita pada hari ini. Okey. Alright, so jadi untuk sesi kita pada petang ini insya-Allah mungkin akan ambil masa lebih kurang 1 jam 30 minit. Okey. Dan pada 15 minit pertama, saya akan orang kata ceritakan dululah mengenai UniKL MFI ni. Okey, dan seterusnya saya akan serahkan kepada Dr. Rifki Izzuan untuk meneruskanlah dengan agenda sesi kita pada hari ini. Okey. Alright, so jadi sebelum kita mulakan, so saya just nak inform lah kepada semua yang ada di dalam sesi kita pada petang ini. Okey, sesi ini juga dijalankan secara live di Facebook UniKL MFI Official. So sekiranya orang kata peserta-peserta yang ada dalam ni lepas ni nak orang kata nak tengok balik nak buat rujukan lah kan selepas ini boleh tengok dekat Facebook UniKL MFI Official sebab kita ada buat live dekat sana. Okey. Alright, so jadi sebelum kita mulakan, so nanti kami akan berikan satu e-form di bahagian ruangan chat. So saya nak mintalah kepada semua yang ada di dalam sesi ini untuk isi e-form tersebut. Okey, supaya untuk dari segi orang kata maklum balas lah kepada pihak kami. Okey. Alright, so jadi saya harap semua yang berada dalam sesi ini berada dalam keadaan yang sihat. Okey, so jadi saya rasa bolehlah kita mulakan sekarang. Boleh Dr. Rifki So agenda kita pada hari ini iaitu mengenai tajuk kita A Guide to Engine Performance ECU Training yang akan disampaikan oleh Dr. Rifki Izzuan daripada Automotive Engineering Section. Okey, jadi saya jemput Dr. Rifki untuk meneruskan agenda kita pada petang ini. Silakan.
Terima kasih Farah. For inviting me. Okay, tanpa dengan masa, I think I would like to share my slide lah about our engine management control. Okay. Okay, I hope you can see the screen now. Boleh nampak Farah?
Boleh Doktor, nampak.
Okay, untuk topik hari ini kita akan share lah macam mana UniKL student learn about the engine tuning. Okay, in general macam saudari Farah beritahu tadi, UniKL kita adalah salah satu universiti higher TVET, so kita menekankan aspek practical dan juga teori kerana kita adalah engineering technology. Okay, kita ada memang kita fokus on dua path of learning, practical and theory. Okay, kita start dulu apa yang student UniKL MFI belajar tentang ECU tuning. Kita overview dan kita share. Hopefully kawan-kawan yang mendengar ni boleh berminat, boleh join UniKL. Okay, in general ni adalah topik-topik yang kita akan mengajar pada student-student kita lah. Kita start dengan key performance parameter, engine performance limitation, ECU, calibration tools, engine function and subsystem, load system. Okay, load system I think is quite old term. Maybe it's the latest term that suit is a system architecture. And then they will learn engine operating state, spark ignition system, fuel injection system, and vehicle calibration. Okay. After saya introduce this topic, I will do some demo lah untuk ECU tuning. Okay, just overview what they will learn about engine key performance parameter. Okay, the first thing first, is the power and torque lah. Kalau power and torque ni, kalau kita cakap dengan orang otomotif selalunya, kalau kat luar ni, biasa orang kata, oh, which one is more important, power ke torque? Power atau torque. Kalau kita tengok dekat YouTube, kalau kita tengok dekat forum-forum, kita tengok dekat website, semua akan kata, okay, torque is much better, peak torque berapa, torque ada torque, early torque, early low speed engine torque, high speed engine torque, semua cakap pasal torque. Tapi kalau you talk to engineers, automotive engineers, kalau kita bercakap tentang vehicle level, we only say power. Never talk about torque. Okay? Tak pernah kita sebut torque ni, tak pernah. Jaranglah, susah kita cakap pasal torque. Kita kalau bercakap pasal engine, kita tak cakap pasal torque, walaupun selalu kita cakap torque curve dia okey lah, torque kat website, kat internet semua cakap torque semua. Tapi sebenarnya as an engineer, we talk about power. For vehicle level lah, for vehicle level. Unless kalau kita nak discuss about component level, kita nak discuss about system level, yes, we cakap pasal torque. For example, engine akan sambung kepada shaft lah, for example. Kita akan bercakap tentang torque sebab kita nak tahu whether berapa torque maksimum engine tu keluarkan, and then kita nak make sure shaft tu boleh tahan torque yang dikeluarkan oleh engine. Kalau sepatutnya design shaft tersebut dia boleh tahan torque lebih tinggi daripada engine. So sebenarnya torque in term of component level and also system level, yes, we talk about torque. But if we say about engine, we talk about power. Okay, about power. And then we also teach them, kalau kita tanyalah student, macam mana kalau kita nak compare, for example, okay, paling senang kalau kita nak compare 2 liter Honda NA dengan 2 liter Mitsubishi natural aspirated, we can compare lah the power, torque berapa semua. Tapi if you being asked, macam okay, diesel 1.6 compare to 3 liter gasoline, mana lagi bagus kan, orang tanya. And then turbocharge 5 liter dengan compare to diesel natural aspirated 1 liter, mana lagi bagus. Atau for current punya situation, we can compare this electric motor compared to the diesel engine, mana lagi bagus. So that comparison, actually we will learn how to compare this engine and that engine, even dia punya CC tak sama, even dia punya type tak sama. Because kalau kita nak cakap tentang engine, the future engineer, the future technologists need to be able to understand this important parameter. Okay, the second thing that we share to the student that they need to know before they start doing tuning to the engine is they need to know the engine performance limitation. Because kalau diorang just tune ikut suka hati, engine akan damage lah, clearly damage. Macam example, the pictures here shown here, macam piston bocor and whatsoever. Kalau kita berkata tentang petrol engine, the simple example limitation is the engine knock lah. Engine knock, kalau engine knock ni dia tak tahu, student tak tahu what is engine knock, and then they just tune, and without knowing about engine knock, the engine can be destroyed in just a few seconds during the tuning session. So they need to know all the limitation before they start doing the tuning. And the next topic is we also will discuss about the engine ECU. Engine ECU aftermarket lah, of course, not the OEM part. Okay, usually kalau kita tanya kat internet, usually there are two options lah. Actually there are few. There are two main option, whether they tanya whether they need to put the standalone ECU ke they want to put a piggyback ECU. So this common question during the class, we will discuss the pro and cons between these two, and how to, even we explain in general how to set up the ECU comparison and so on. Okay, this one is also very important lah, so they can make the good decision which ECU they want to install before they buy one. Because ECU ni bukan murah, I can say the ECU sometimes can cost you about 5,000, 3,000 and so on. So it's quite expensive before you invest, you need to know in some details. Okay, next topic that we will share to the student is about the calibration tools. Okay, from the biggest one to the smallest one. So in general, from the biggest one is the chassis dyno, the engine dyno, and also other things like the communication tools, the AFR, the lambda sensor and so on lah. Okay, And even we also discuss what is the difference between O2 sensor, AFR sensor, and lambda sensor. What is the difference? Actually, there also discussion on that. But yeah, we discuss on the student need to learn on the calibration tool before they start the tuning. And later on, I will share also how the student do the practical using the chassis dyno and also the engine dyno in UniKL MFI. Okay. Right now they are starting to go more deeper to the ECU tuning. Okay. Then after they be introduced to the calibration tools, they need to learn more about the subsystem and the engine function. Okay, paling simple engine function that I can give you right now is the throttle controller, throttle body controller. Okay, for example, when you press 10% of throttle pedal, tekan minyak dekat drive as the driver tekan minyak tu 10%. For example, 10% throttle body kat engine tu buka 10%. When you press 20%, 20% dekat engine. So that is a simple example. But when you can control or you can tune, you can make it more aggressive. For example, when you press 10% at the pedal, the engine throttle opening can go straight away 50. When you press 20%, the engine can go straight away 100%. So you can feel the engine more aggressive and more responsive. And also you can make it opposite lah if you want to. And I think this is one of the simplest way for the aftermarket item lah. They want to sell to people to have a better engine power performance, but actually they just change the throttle control response. So that's the thing that they can do. Actually, there are a lot of functions that I will share later during the demonstration. Okay, the next one again is, I think the load system is a bit old term. I think the best term is the architecture system, because the early stage or the first ECU, it was developed based on the throttle body position. Okay, throttle body position here. Okay, for example, when they open certain throttle body, the fuel will inject and certain amount. So that's the early stage. But the problem is this early architecture, when the throttle, for example, open 50% at the ground sea level compared to the throttle 50% opening at the highland, the air pressure going inside is different. For example, the air at the ground level is 1 bar, but the pressure at the highland may be 0.8 bar, for example. So the amount of oxygen molecule enter to the engine is different, even though the throttle body opening is the same. So actually it's not very robust enough. Then the new architecture emerged, which is the MAP, the pressure base or the speed density, you can call it. It based from the pressure that going into the engine. There is a pressure sensor that they put, so they measure the pressure and then they can estimate the amount of air going inside. This is also a much better compared to the throttle, because they can generally estimate how much the air going to the engine, so they can give a more accurate fueling. And there are another architecture that use a airflow sensor, so they can measure the airflow going inside the engine. They are a bit similar but a bit different in terms of architecture. Okay, the latest architecture, I think, is not being well known in Malaysia, especially for the individual tuners and so on. Is called torque-based architecture. And why torque-based architecture be introduced is that some features you cannot be done using the speed density architecture, the flow rate architecture, or even the throttle body architecture. Simple example that the torque-based can do compared to the other is that the torque-based architecture can do the traction control system features. Because for example, when you race, you slam the throttle body, we doesn't want the wheel spin on the road. What we want is the vehicle to move forward. So we have by having the torque control architecture, they can control the torque amount to the tire to make sure there will not be no wheel spin when you slam the throttle pedal. So that is what we call the the torque based architecture. And the torque based architecture is already so common in the OEM, even to the electric vehicle. Okay, and then the student also need to learn different state of the vehicle. For example, when the engine start from the cold condition, the engine different strategy need to be done. When the vehicle want to have a very high power, for example during the race, the strategy need to be different. And for example, when the vehicle going down a hill, the strategy will be different. So they need to know, because it will not be the same strategy between the operating state. And then they will go a bit more deeper and deeper into the spark ignition system, how it be from the base map into the final spark, and also the fuel system from the base fuel to the final fuel injection amount. And lastly, they need to learn how to do the vehicle calibration, because engine calibration, what I told you just now, is more or less about the vehicle, more or less about the engine calibration. But if you just tune the engine, your driving experience will not be very good. For example, when you shift your gear, the feeling is not good. Maybe there will be a bit of macam tersengguk-sengguk lah, kan, masa driving tukar shifting, atau maybe during you slam the floor of the throttle pedal, your vehicle will not move as fast as you wanted. So this part, what we call the vehicle calibration area. Okay, it need to be done to make sure that when you drive, you can get the best feeling. But for the engine part, is to make sure that we can get the optimum performance from the engine. So this is the area of what they will learn. Okay, now I will share you some videos showing what do the student do during practical. I hope you can hear the sound. This is some demonstration by the student. One of the sorry, a bit stuck. Okay. But your voice cannot be heard. for ECL Automotive manual, we are having an additional capability you can put a lot of kind of activity that you will of that. Okay, that one is the chassis dyno practical done by the student. Okay, this one is the engine dyno done by the student.
Sir, would you mind to slow down the video music, please, sir?
Okay.
Explanation tak dengar, sir.
Okay. I hope now it's okay. Okay, for this now, some demonstration virtual engine test in the right now. Okay, now part. Now the testing very thoroughly the wiring, the post, the engine, and now they are starting to power up the engine. Okay, right now we are what is that? This is a fan. Electrical system for the powertrain on our infrastructure. Okay, this is the actual motor that we already have installed in a double-decker bus. And you can see on the bottom left corner is the gray box is the battery. The both battery weight is around 1,000 kilogram. So it's actually a part battery and it's actual scale. Actual scale is an actual scale. And this is also one of our and we will also teach them how to do the electric vehicle tuning. That's all for the demonstration. For the thing that we teach to the students. Okay, right now, if you have any question, just let me know. We can have a discussion. Okay, right now I will show some demonstration of engine tuning. For your information, in UniKL Bangi, UniKL MFI Bangi, we have two standalone ECU. The first one we have Haltech, and the second one we have Motec. So the Haltech we focus on the vehicle level, and the Motec we are focusing for the engine only. So you can imagine that the Motec is only can be tested in the engine dynamometer, and the Haltech is only can be tested on the chassis dynamometer. So this is the software for the Haltech system. The Haltech system, actually the software is actually you can download it freely. So it's a good thing because maybe you can learn after you download it. Of course, I cannot demo a live engine because yes, the vehicle is at the campus, right? But anyway, I try my best to show you how the tuning will be done. Okay, this is the first page when you just opening the software. They call the ECU manager. Okay, first thing first is either you try to connect to when you have the vehicle, you can connect directly the ECU, and then you can just press this one, and then you can get the database from the ECU, or you can just open some example or some save file that you already done. So for example, we have the Proton and we have the Satria Neo CPS supercharge. Okay, this supercharge, for your information, is the yellow car that you saw during the testing in the video just now. So this is the car that are running with the Haltech ECU. And if you ask me, this is the Haltech Platinum Sprint model. Okay. Alright, this is the ECU page when you opening the Haltech software. Okay, first thing first, when people ask you, you need to calibrate my engine, and then what you need to do. Okay, first thing first, you need to learn about the engine physically. Okay, physically, without knowing the engine physically, how you want to control the engine properly. So make sure that you know what kind of sensor, what kind of the displacement of the engine, what are the features that have the engine, because sometimes the engine have the variable valve timing. Some engine have the CPS function like the Campro CPS. Some engine have like the turbocharge. Some engine have supercharge and so on. So you need to make sure you know every single, not every single component, physically you need to know in detail so that you can properly tune the engine up to its optimal performance. Okay. And then the first thing that you should do is you go to the main setup. Okay, this one is already there. The map is already there, but we'll go one by one. Okay, you go to the main setup. After you learning all single thing that you need to know about the engine physically, then you try to key in all the information in the system. Okay, this one I will tell you later because they are in the Haltech system. There are two architecture that been promote, which is the injection type, injection time architecture, and also the VE architecture. Okay, and then you need to put how many cylinder, because this cylinder determine the firing order, and then you can choose whether you want to have a MAT architecture or the TPS. TPS means the throttle position sensor architecture. Like I mentioned, the architecture different based on your requirement. But usually, the TPS is not that very robust because sometimes it cannot estimate the actual air that going inside the engine. The better one will be the pressure. And also this one telling you are using the map that on the engine. And cranking speed is make sure that you tell the ECU that the engine already started or already have combustion started. So anything above this speed, the ECU know that the engine already starting to combust inside the combustion chamber. And of course, this the RPM display maximum is the limit for the engine that you set, right? And then this is the first page that you need to do, okay? And then the second thing that you need to do is setting up the physical item also is the crank sensor and the cam sensor. Okay, why this is very important? Actually, this is the first thing that you need to do, or I say in terms of setting up, that quite take a bit of time for some of you, especially really custom-made engine. You need to make sure that you need to able to tell the ECU the position of the piston, or whether the piston is going up or down and so on. So this is the setting when you can tell the crank position, you can tell the cam position, and then the ECU will know actually where is the piston right now. If because from there they know where to inject the fuel, when to ignite the spark. Okay. I also will not go into detail. Okay. But in general, some of it already have, like for example, Nissan, Subaru is already there because this type is very different compared to the common type. But if you want to go to the common type, just go to the Mototronic and you can count the teeth of the crank sensor. For example, in general, for Proton, we have 60 teeth on the crank sensor and -2, which means the -2 missing tooth, and also one means that they have one signal of the cam sensor. So this generally the most of the cars lah. Okay, but it also have other type of sorry, like Evo, Ford, and so on. And then you need to tell what kind of physically fuel type is the engine are using. Okay, in general, I can say that most engines are using sequential lah. Most engines using sequential, unless you want to have a different type of injection fuel injection system. Okay, if you want to ask in detail, okay, you can ask later on. Okay, and also you need to mention what kind of ignition spark that the engine are running with. Okay, for CamPro, for your information, it is running with the spark mode, which means that it will spark once per cycle. Okay, actually for 4-stroke, you will need to ignite once for every 2 stroke, but for Proton, it ignite for one time per cycle, which means one spark will spark during the combustion and another one will spark during the exhaust. So that's the system that Proton are using. Of course, there are pro and con, which of course need to have a further detailed explanation. Okay, this is the thing that you need to do. Firstly, you need to tell the basic physical of the engine. And then you, of course, this the much more thing about the engine. Okay, this one is more about how you want to control the engine. Okay, how you want to control the engine. Okay, the very basic thing is that there is no all of this feature. Okay, Okay, this no feature. So if you doesn't want any of these special features, it's actually gonna be a very simple calibration. So you can see there is only a few map, fuel a few map, and the ignition a few map. Okay, so very simple, and that's it. But you will not run the engine very well. Okay, that's the problem. But for start, you can use this kind of setting. Okay, just to brief you one by one, because it's very important for you to know what is this. This what we call the subsystem of the sub function of the ECU. Okay, O2 control. I can say that most of current vehicle OEM have a O2 control, and it's a very good thing because as a tuner, you know that you cannot tune your engine perfectly all the time. Okay, because when you drive, sometimes during the night, the environment is different, and then sometimes when the driver drive the vehicle in the hot afternoon, the environment will be different. So automatic control will help your tuning engine ECU accuracy. The acceleration card is something that I think already common. Okay, already common is where when you this very important example when, for example, when you go downhill, you drive downhill, usually you will not press the pedal, you will just let go the pedal. So during this time, the engine speed still very high because the vehicle speed is very fast going downhill, and during this time you don't want to have any fuel injected because it will be a waste, because you just want to engine during this time do not spark and do not inject any fuel. Okay, so it's very important. If you inject fuel, there will be combustion, so it's not good because you want to drive slowly downhill. So this that function. And overboost, just to protect the engine. If the engine detect the boost is higher than the target threshold, we will shut down the spark or the fuel to protect the engine. The rev limiter of course you will limit the engine speed, because when it goes certain speed, there will be unwanted things that will happen. For example, the valve floating and so on. So you can put the rev limiter, the transient throttle enhancement. Okay, this is where to make sure that the vehicle can run smoothly when you drive to slow to fast to slow and so on. Because if you don't have the transient throttle enhanced, when you press the pedal, the engine will be like a bit suffer a few seconds before it can catch up with the fuel and correct air and fuel ratio. What happens when you press the pedal suddenly? A junk or a big group of air going to the engine without any fuel. That will make the engine a bit like a misfire feeling. So this is very important. Gear setup. If you want to set up the gear, this rate showing error because we need to mention there is a sensor measuring the gear setup. And then you can also go into detail how to the O2 sensor. Okay, need to be controlled. Okay, so you need to also know the narrow band, the wide band. Okay, I will not go into detail. The acceleration just now you can configure the engine speed limiter, the overboost, and so on can be controlled, can be configured. Okay, the other subsystem that you need to know, right now the number of map is very low for the fuel and ignition. The base map is there, but we need to add a more system to make sure that the engine can run smoothly in all conditions. For example, the post start table, okay, the post start spark ignition both have, because when you start, usually the fuel need to be more and the spark need to be advanced. So if you don't have any that have function, usually your engine a bit struggle to start, because starting engine will be different compared to normal running engine. Okay, and then you have the air temperature correction table for both fuel and spark. The air temperature correction, because when the air is hot, you know that the density of the air is low, which means the number of oxygen is low. So the engine need to know that. Also for when the air is cold, the density is high, the oxygen also higher. The engine need to know that. So when the engine know exactly what happened to the air, so it can really have a very accurate control of the engine output. And then they also have the coolant temperature correction, which means that when the coolant is hot, actually all the engine block will be hotter, cylinder head will be hotter. When the engine block hotter and cylinder head hotter, the combustion also will be affected. Okay, for example, when the coolant is very hot, creates the high temperature combustion chamber, and the engine can easily be knocked. So the engine need to know that the coolant temperature, and also the vice versa, when the coolant temperature is very low, it's hard for the fuel to combust. So the engine also need to know that, so they can do something with it. Okay, map correction table. This is if you just want to use the throttle position architecture, which is not very important if you are using the volumetric VE architecture. Okay, zero throttle. Okay, zero throttle usually also relate to the idling. Well, if you have a very high idling, zero throttle is gonna help you. Okay, you can, because sometimes when idling, sometimes the pressure sensor cannot accurately measure the pressure going into the engine, because sometimes there are fluctuation because the engine speed is very low. So it can the ECU cannot really know how much is the air going inside the engine. So zero throttle table gonna help that kind of situation. Okay, wide open throttle table. This is when you want to have a sudden power, extra power. You can have this one. Okay, this is when, for example, when you press the throttle pedal more than 90%, you want the fuel to be extra more compared to the normal running. So you can have this kind of strategy. Barometric correction also for the throttle position sensor architecture, which is not important for normal, because throttle body architecture do not know the air, so this can help the throttle architecture. Okay, prime table, because the fuel from the fuel tank will take time to the engine, because usually if the fuel is at the back and the engine is in the front. So this is to know that the fuel pressure is not gonna increase exactly when you start the engine. The fuel pressure will increase gradually, maybe 3 seconds, 4 seconds after you start the engine. So you can tell the ECU that there are lack of fuel pressure. Okay, so the engine know, and then the engine can do something about it. The dead time table. Okay, the dead time, which means that you tell the ECU that the injector have a dead time, which means that, for example, you say that you want a 10 millisecond open valve injector opening, but sometimes there are a dead time 1 millisecond. So actually, you want, if you key in 10 millisecond, but the actual injection is only 9 because it have 1 millisecond dead time. Okay, usually dead time is related to the battery voltage. Okay, battery voltage. If the battery voltage very high, the injector valve can open very quick. If the battery voltage is very low, the valve injector is hardly open as fast as the high voltage. Okay, this is the thing. Okay, okay, this one I've explained, and then you can have the output, which means if you want something like a tachometer, which like the RPM meter, big RPM meter, it also can provide the information to the driver and other things. And also input. Sorry, input is something that you want engine to know. Engine to know. Okay. I will not go more detail here because this one is not that important. I will go here. Okay, this one, the throttle position sensor. This one, you need to tell the engine how the throttle position behave. For example, during the zero totally close, the throttle position is at what voltage, and when it's open 100%, it run at what voltage. So you need to tell the ECU this one to make sure that the ECU really know the position of the throttle. Okay, the map sensor is the mass air pressure sensor. You need to know, because the engine only receive in voltage, you need to mention to the ECU this certain voltage represent what pressure. You can see here the 0 volt represent the minus 100 kilopascal, and the 1.9 volt represent the 0 kilopascal, and 5 volt is represent 150 kilopascal. Okay, this is kilopascal. This is ambient pressure relative, right? Okay, very quick on that. And also you need to tell the ECU the temperature sensor, okay, the coolant temperature sensor from voltage information to the actual temperature. You can see here. And also the air temperature sensor, the same thing. The O2 sensor, same thing. Okay, this one, the auxiliary ref limit. Okay, this one, okay, this is the problem when we say about the architecture that are running under Haltech right now, because under top base, the ref limit is much better. Okay, much better. So for this one, which means that when you rev the engine, okay, rev with no running, it can only rev up to 3,000. This is the strategy for you to help you launch the vehicle, something like that. But it's not as good when you have the torque-based architecture, because it can really control to the precise torque that for the tires to launch the vehicle perfectly, right? Okay, the wideband. Okay, wideband sensor, you can tell the ECU what kind of wideband sensor that you are putting into the system, and also the device, right? Device, which means that maybe you have something other that you want to integrate with the current ECU, right? I think this is not very important for early stage. Oh, sorry. Okay, there's no map here. I didn't press OK. Okay, if you have selected what kind of control strategy that you wanted, you can see there are a lot of maps here that you need to tune in general every single number. Okay, for beginner, this is quite overwhelming, because there are a lot of things that you need to key in, and we can say that where to start, because there are a lot of tables here, and maybe some people stop right here because they do not know how to start the tuning. Okay, to make it simple, okay, if you are a beginner tuner, the first thing that my advice is that you try to get all the map that other people already done on the vehicle, because that's gonna help you a lot, saving a lot of time, right? If not, if you don't have the map, for example, you have make a special fabricated engine, so there is no reference that you can use or no previous data. So which means that you need to do on your own every single cell. Of course, not every single cell, the important area. Okay, first thing first, you need to focus on the base map, both for the fuel and both for the ignition. Sorry, let me check what kind of architecture is this. Okay, I think I prefer VE. Okay, right, the base map. Okay, the base map, before you start, you need to focus directly on this area. Okay, this area, which is the during idling. This is area during idling. You can see the idling is around 1,000 to 500. Okay, and also 1,000 to 500. So this is the thing that you need to focus. So first thing first, you try to tune on this area so that the engine can idle properly. right? Idle properly. And then you try to during the idling, you just leave the engine idling at what RPM that it running at, as long as it running. Okay, and then you try to tune the idling as low as possible as your target. For example, you target at 800 RPM, you need to tune the spark, especially the spark, because when you advance the spark, the engine idling tends to be higher. When you retard the spark, the engine idling tends to be a bit lower. So then you need to adjust the spark timing according to your engine RPM, idling RPM target. So you need to focus on here, and then after you manage to get a proper stable idling, then you can start with other location. Okay, other location. Alright. In general, what do they do is that they will run. If you have like UniKL, at UniKL Bangi, we have a chassis dyno that can control the vehicle speed. Control the vehicle speed, because when you have the control vehicle speed ability, you can tune this line by line. Okay, line by line. If you wanted to detail, you can do it to detail, or if you want to make it very simple, you can make it very simple. So you can have line by line. Okay, something like that. Or if you doesn't have chassis dyno like UniKL, you have a normal chassis dyno, a drum type chassis dyno. Yes, you will tune a bit where a bit bigger area. Okay, a bit bigger area until you certify what you want the performance as you wanted. Okay, that's the basic idea. Of course, there will be a bit more that I need to explain, but I think that it will be too much time. And of course, I need to also to explain you about the VE, how the engine react to the VE architecture and so on, but it will be take more longer time. But I think I need to end here. If you have any question, just let me know. Okay, just let me know. Okay, thank you. I'll bring back to Farah.
Alright, so thank you. Terima kasih kepada Dr. Rifki Izwan atas penerangan yang diberikan. So jadi kita pergi kepada agenda seterusnya, iaitu kepada question and answer. Sekiranya semua yang ada di dalam sesi ini ada soalan, boleh diajukan terus kepada Dr. Rifki. Silakan. Okey, ada soalan? Ada sebarang soalan? Okey, so Dr. Rifki mungkin ada sebarang soalan yang ingin ditanyakan daripada semua yang berada di dalam sesi ni lah. Okey, so jadi saya juga nak minta maaf kepada semua. Okey, sepatutnya ada alumni kita yang akan join lah pada sesi petang ini. Tapi dia ada sedikit masalah, so jadi dia tak dapat untuk attend lah dengan sesi kita pada petang ini. Okey, so jadi saya minta maaf lah kepada semua.
Hello.
Hello, ya.
Hello. Saya nak tanya kat doktor.
Silakan.
Yang tabel yang banyak tadi tu, adakah kita perlu tune satu-satu untuk dapat nilai tu? Ataupun dia dah ada macam dia punya formula ke, atau dia punya number dia yang dia dah bahagi, cuma kita perlu isikan ke, macam mana benda tu?
Okay, my comment is that dia depend on setiap orang lah, Ada orang yang a bit detail, memang dia nak isi setiap every single kotak yang ada. Memang ada orang macam tu, dia nak isi. So tapi kalau kita isi kotak every single kotak, memang agak apa orang kata, agak macam tak siap-siap lah, maybe take a very long time. Tapi for beginner, for example kita nak buat engine tuning, target kita adalah untuk race drag for example. So kalau kita nak fokus on race drag, tak semua map yang kita kena tune. For example, kalau race drag actually maybe you need to focus on few table, maybe on the base map only. Kalau you want to go more critical, boleh buat macam ada temperature compensation sikit kalau perlu. Tapi bagi saya, if you go for the base map, actually dah okay lah. And for the very basic, and then kalau of course kalau kamu ada masa, and of course go to detail, because bila lagi detail, lagi smooth, lagi accurate, ataupun lagi better engine to handle in different environment. Because kalau during gas track pun temperature pun berubah-ubah kan. Sometimes kalau tiba-tiba temperature track tu panas, tiba-tiba knocking, so kita tak nak, kan, tak nak knocking. So macam tu lah. So depends on kita punya target. Okay tak menjawab soalan? I hope that answering your question lah.
Jawab doktor, menjawab. Terima kasih doktor.
Okay.
Ya, silakan. Cik Badrul bin Hashim. Silakan.
Tengok juga dia punya kemampuan gearbox. Saya tak faham kenapa relate dengan gearbox.
Saya tak berapa dengar. Adakah apa yang saya sebutkan top base?
Suara Encik jauh.
Tak dengar Cikgu Bat.
Okey, sekarang clear dah?
Okay.
Better.
Alright, better.
Dah dia punya dyno mapping stage 1 kereta saya lah. And then saya berbual dengan tuner tu, dia tanya ada limit tak? Dia kata dia buat mapping tu based on limit. Kena tengok juga limit torque yang boleh diterima oleh gearbox. So, macam kita saya limit torque gearbox mesti not more than 500
Newton.
Dia kata macam tu lah. Adakah ada, kenapa dia perlu ada, kena tengok tu. Terima kasih.
Okay, that's very good question lah. Kalau you are engineer, memang that question is very important lah kalau engineer. Kalau kita nak buat engine and then couple dengan gearbox, that is very important question, very important value. Tapi saya tak sure lah untuk kereta luar, unless kalau engine tu terlampau kuat compared to the stock transmission, yes, memang kena ada limitation. Tapi kalau tak jauh sangat, tak ada beza power, should be okay. Because memang kalau engine tu torque terlampau tinggi, first thing first, kita tengok clutch dulu. Before kita tengok gearbox, dia akan transfer the torque to the clutch. Kalau clutch akan fail dulu. Okay? Kalau kereta auto, torque converter akan problem. And then memang kalau benda ni dah jam apa semua, akan transfer direct to the gearbox, akan problem pada gearbox. Yes, that's very important parameter. Tapi saya tak sure lah kalau tuning kat luar, tune terlampau kuat, baru okay kita nak consider. Tapi kalau just a few horsepower, I think should be okay lagi. Tapi depend lah, saya tak kena tengok dulu kereta.
Yalah tu memang dia beritahu dia pernah buat kereta dia Mercedes tu sampai pecah tak converter tu. Itu
I see.
Satu lagi. Tuner ni bukan berkenaan dengan enjin saja kan doktor kan. Ada tak kalau flash gearbox itu adalah mengena dengan tune gearbox flash.
Okay, gearbox. Okay, flashing lah, flashing. Flashing ni bukan saja gearbox lah. Gearbox engine pun boleh flash, gearbox pun boleh flash. Any ECU, any control unit flash. Flash ni macam kita upload file kan. Easy word is upload file pada control unit system tu. Kalau soalan Encik Bat tadi dekat transmission, actually transmission pun kena tune. Okay, transmission pun kena tune, tapi saya rasa jaranglah ada orang tune transmission. Tapi usually kalau dia ada pun dia just flash lagi senang lah. Sebab jarang saya rasa ada yang orang tune gearbox. Tapi memang actually kalau gearbox memang kena tune. Kalau tak berapa optimize.
Sekarang popular orang flash saja gearbox ni sebab dia nak rekan kereta dah lama kan. Dia punya yang baru-baru nak follow, nak upgrade dia punya ni software dah baru kan. Okey, terima kasih Dr.
Okay, thank you.
Okey, Dr. Rifki ada juga yang tanya dekat bahagian ruangan chat. Okey, so daripada Zaki. Katanya turbo wajib pakai forged piston. Apa maksudnya tu?
Okay, forged piston ni in general kita boleh katakan piston yang lebih tahan lasak lah. Lebih tahan lasak. Tapi kalau soalan ni macam very open question, turbo wajib pakai forged piston ke tak? My answer is not lah. It's not wajib. Again, kalau of course kalau you are planning to put more boost than normal piston punya limit, yes, forged piston is a must. So it depend. Kalau certain orang biasa nak tune ni, kalau nak tune terlampau high boost ni susah. So dia bagi boost tinggi sikit je. So forged piston is not wajib.
Okey, harap menjawab soalan daripada Zaki. Okey, so kita ada soalan seterusnya di bahagian ruangan chat juga. So untuk tuning ni di UniKL ada belajar untuk tune carburetor system.
Okay, that question actually carburetor system ni not under the topic lah, under the topic and not under practical. But what I can say about the tuning carburetor ni, we have the expert lah dekat we have the expert. Kalau student nak tanya, dia boleh go to our expert about the carburetor tuning.
Alright, so mungkin lepas ni kita boleh cerita pasal tune carburetor pula ke kan? Dr. Rifki selepas ini kan? Okay. Ada soalan ke nak tanya? Aya, silakan.
Apa beza flash dengan tune ni Doktor? Ada benda yang sama atau perkara yang berbeza?
Okay, flash ni actually word for electronic punya orang lah. Saya rasa kalau flash ni kalau kita pergi ke orang elektronik, diorang lebih familiar. Actually for automotive ni, I think kalau siapa yang bekerja dengan ECU, baru dia familiar lah. Flash ni bagi saya dia macam upload file. Kan? Tu je actually term dia. Flash ni upload file. Contohnya, kenapa kita upload file? Contohnya kita ada data yang dah ditune, orang katakan daripada US, kita download pada internet and then kita upload tu dekat ECU. Upload ke ECU tu kita panggil flashing. Itu saja.
Oh, okey. Faham. Masker sebab tu macam mode 3 dia ada consider jual dia punya. Ya. Okey, terima kasih.
Okey, so doktor ada juga dekat ruangan chat lagi. Okey, daripada Muhammad Asfa Amir. Salam doktor, apa maksud remap ECU?
Okay, remap ECU ni kita contohnya ada map asal, maksudnya map tu apa? Ada fuel timing yang asal, contoh katakan 10 millisecond katakanlah. Tapi remap ni dia tukar balik semua value-value ni. So in general that mean what we meant by remap ECU lah. Dia tukar balik the whole figure tu dekat dalam table tu. Table tu nampak macam map, tapi sebenarnya adalah table lah. Table apa macam Excel tu, tapi that what we call map. And then kalau dia tukar semua number, is a remap lah, what we call remap.
Okey, baik. Harap menjawab persoalan daripada Muhammad Asfa Amir. Okey, so ada juga soalan daripada Muhammad Jun, MD Jun. Okey, sekejap ya. Maaf. Okey. So kita terus kepada Hazarul Kevi Kajang. Soalan, sesetengah tuner akan copy mapping dan paste tanpa kenderaan itu sendiri di dyno. Adakah ia akan memberi kesan pada karakter sesebuah enjin kenderaan?
Okey. So dia depends on how kita nak tengok benda ni. Kalau you cakap kepada orang yang very detail, particular, dia akan jawab no. Every single engine is different. Every single engine. Even kalau kita katakanlah kereta Proton yang jual berpuluh-puluh ribu, kereta Pro 2 jual berpuluh ribu, ada banyak puluh ribu engine tu, every single engine is different. Tapi how they do it is they have a margin lah to make sure all different engine ni boleh run as accordingly lah. Actually kalau you tanya orang yang detail, that is the jawapan dia macam tu. Tapi kalau tanya in general, yes you can, but it depend. Kalau engine tu too much different, you will be affected. Kalau tak ada banyak beza, it should be okay.
Okey, harap menjawab soalan daripada Hazarul KV Kajang. Okey, alright. So, ada lagi soalan? Okey, daripada Muhammad Irfan. Doktor, kenapa dua buah kenderaan yang sama model guna valve spring yang sama but different top apa ni?
Top rev. Okay.
Top rev. Apa punca ya? Terms automotive ni.
Soalan very relate to my previous answer lah. Macam saya kata, even katakanlah engine Pro 2 kan. Kata my VA dengan my VB engine spek semua sama, tapi sebenarnya kalau you go to detail, it's not identical lah, because kadang-kadang even piston size pun actually different if you go in detail. Kalau you go to the OEM, memang dia akan beritahu piston size every engine will be different. So to answer your question, valve spring yang sama tapi different rev, top rev, yes, because sometimes the manufacturing untuk buat valve spring tu is not perfect, tak perfect. So there are chances that dia punya rev dia punya rev potential is different. Tapi it shouldn't be very far lah. Kalau you buy from company A punya valve spring, orang tu pun buy from valve company A punya valve spring, it shouldn't very far. Maybe very minor different. Kalau very far, maksudnya ada physical abnormality. Most probably.
Alright, so terima kasih Dr. Rifki. Okey, kalau ada lagi soalan, kalau nak dapatkan file untuk flash, ada website kursus untuk ECU? Tanya.
Kalau ada file untuk flash, okey. File untuk flash ni saya rasa ada certain, saya tak follow all the aftermarket punya flashing member and so on, but I know that there is kalau you join, for example, certain forum, there is a file that you can download and then you can just flash to the ECU. Of course, you need to have the mechanism to flash lah. Sebab macam mana nak flash kalau you tak ada tools untuk flash kan. Tapi yes, there is a file that you can download. But exactly, you need to tanya orang-orang yang punya grup kenderaan tersebut lah. Kalau khusus website untuk ECU ni, I think the very basic early stage, maybe you can go to Google and so on. Memang dia akan terang explain everything. And if you want to know more, come to UniKL lah. Yeah.
Alright, okay, so terima kasih Dr. Rifki. Okay, so jadi kita buka kepada soalan terakhir. Okay, so jam pun dah menunjukkan 4:29. Sekiranya ada soalan terakhir yang ingin diajukan, okay, silakan, boleh on mikrofon. Okay, so jadi tak ada soalan terakhir okay, so okay, see you on September. Okay, ada soalan yang terakhir dekat ruangan chat lah. Okay, so Doktor, base map engine diesel boleh guna dekat engine petrol?
Okay, kalau you ask for technical person yang can do anything, yes, they can say that it can be done. Okay, can be done. Of course, it's not as simple as you think lah. Tapi kalau you tanya most of the people, no lah. It's because the fuel punya strategi different. Because fuel kita main dengan throttle body position, kita main dengan spark timing, we play with fuel. Tapi kalau for diesel, we play with fuel. So it's totally different thing. But kalau you tanya orang yang boleh buat, betul-betul boleh buat, memang dia boleh buat.
Okay, alright. So terima kasih kerana Dr. Rifki menjawab soalan yang terakhir kita lah. Okay, di bahagian ruangan chat. Okay. Ada lagi. So kita pergi kepada last lah okay. What is the parameter used to tune EV vehicle?
Okay, this depend on what view you want to look lah. Because I think I can divide it into three lah. First, the electric motor, powertrain. The second part is the battery, and the third part is the vehicle lah. So kalau you kata pasal motor, it depend on motor type. So because kita nak, for example, control for EV, for motor, kita boleh control whether how you want to the electric motor to behave lah. Tapi kalau for battery, kita nak control macam mana dia make sure dia boleh jadi buat maximum current dia can supply in general. Tapi kalau for vehicle, is how from the throttle body yang kita pijak minyak tu, how it translate to the top base reading. In general tu yang saya boleh terang, tapi in detail of course ada detail lagi. So you boleh contact saya, you can have a further discussion lah.
Alright, okay. Jadi terima kasih. Okay, itu merupakan soalan yang terakhir lah untuk sesi kita pada petang ini. Jadi sekiranya ada lagi soalan kan, macam Dr. Rifki cakap lah in detail lagi, mungkin memerlukan explanation yang lebih panjang daripada Dr. Rifki. So boleh contact dengan Dr. Rifki lah melalui email lah. Ada dekat skrin tu, rifki@unikl.edu.my. So insyaAllah nanti Dr. Rifki akan membantulah dari segi untuk explain segala persoalan yang diperlukan lah mengenai tajuk kita lah pada hari ini. Okay. So jadi saya nak ucapkan terima kasih kepada Dr. Rifki atas penerangan yang diberikan. Okay. So sangat bermanfaat, banyak information yang diberikan lah untuk sesi kita pada petang ini. So diharapkan sesi kita pada petang ini juga memberi manfaat kepada semualah yang join untuk sesi kita ni. Okay, so jadi kita target dalam masa jam setengah. So jam pun sudah menunjukkan 4:30. Okay. Alright, so jadi saya nak ucapkan terima kasih sekali lagi kepada semualah yang hadir untuk sesi kita pada petang ini. So mungkin akan datang kita akan buat lagi sesi yang berbeza juga untuk otomotif. Okay, apa isu yang akan dibincangkan, so kita akan share nanti. Okay. Alright, so jangan lupa, sekali lagi saya nak ingatkan, so jangan lupa untuk isi e-form yang diberikan di dalam bahagian ruangan chat supaya mudah untuk kami blast sekiranya ada lagi sesi yang akan datang nantilah kan yang berkaitan dengan otomotif ni. Okay, alright, so saya rasa itu saja untuk sesi kita pada petang ini. Okay, so saya just nak ingatkanlah kepada semua, so jaga diri. Okay, stay safe sebab kes pun makin tinggi. Hari ni pun kes pun tinggi kan, 21,000. Alright, so semua jaga dirilah, jaga kesihatan. Okay, insyaAllah kita akan berjumpa lagi di lain waktu, di lain sesi. Okay, sehingga berjumpa lagi. Assalamualaikum dan selamat petang. Terima kasih semua.
Waalaikumsalam.
Terima kasih Dr. Rifki, terima kasih Cik Dilan, thank you Farah, thank you semua yang hadir hari ni.
Yes.
UniKL, kita datang. UniKL, kita terbilang.
Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Menjadi cemerlang. UniKL. Wow, UniKL. Satu amanat kita junjung sama, tak kira di darat, laut dan udara. Cium tangan mama papa, tanda janji, kata pasti di kota, buktikan pada mereka. Bawa akal, jadi bekal, ikut padi, untuk berisi selamat jiwa. Dikandung kental, menyerah kalah, tolak ke sisi. Wow, kita datang. Wow, kita datang. Wow, kita terbilang. Wow, kita terbilang. Mencari peluang. Menjadi cemerlang. UniKL. Wow, UniKL. UniKL. Wow, UniKL. Satu matlamat, terbang gapai mimpi, renangi era baru, kejar misi frekuensi, pengemudi angkatan, nahoda ke